Hello dear student, today we will be going to start our journey with this topic, that is the operational amplifier IC741. Myself Harshal sir. So let us start our topic. IC741, that is the operational amplifier, is more popularly known to all of you. The IC741, it is the 8-pin dual line-in package form of IC, which is consisting the pin number 1, 5 and 8. First one, these are the no connection type of the pin. Okay, now here pin number 2, it is inverting pin, and pin number 3 is the non-inverting pin, which is the positive. Here we want to record the two supply, that is the plus VCC and minus VCC. A minus VCC, it is mostly we use the minus 12 volt, and plus VCC we use the plus 12 volt supply. Pin number 6 is the output pin. This is the circuit symbol of operational amplifier 741. As already we have seen here, the pin number 2, it is the inverting pin, that is the negative. Pin number 3 is the non-inverting pin, it is a positive terminal. Here we want to record the two supply, positive VCC and negative VCC. Pin number 7 is required positive VCC, pin number 4 is required negative VCC, pin number 6 is the output. Here we already seen the name of this terminal, that is inverting, non-inverting, output voltage and voltage gain. Any one amplifier, the output voltage, which is the depend upon the gain, that is the A parameter, and the input variable. Here in the operational amplifier, why we call the operational amplifier? Because this amplifier, it can be performing the mathematical operation such as the addition, subtraction, multiplication, division, integration, differentiation, as well as these IC 741 also act as comparator, compare the two signal. It is also used to oscillate the signal, to generate the oscillation, to the filtering. It is also act as rectifier, and the many more application is done within the single IC. That's why this is called the operational amplifier. Okay, so here what is meant by the amplifier? One thing is there. Here if we increase the input signal, and amplification is a 10 time, according to that our signal is get increases. Again we decreasing the amplitude of the input signal, then amplitude of the outside, it will be going on decreasing. So this is known as an amplifier. Amplification is done due to the gain. So V output is equal to what? It is the gain of your input signal. The output signal is depend upon the gain. Okay, here 10 times gain, we also use the 100 times of gain. According to that, signal amplification done in the large form. Okay, why the op-amp having the performing this lot of application? Due to the some ideal property. Which are the property? First one, the infinite gain. Their gain is the infinite. Their gain is infinite. That means the output, their output is depend upon the input and feedback also. Next one property is the input impedance is the infinite. Here their input resistance is infinite. If this input signal is infinite, that means the speed vector is the larger one. So our vehicle, which is run by the person, is moving slowly. That means large amount of signal we can apply without damaging our op-amp. Next one property, their bandwidth is infinite. Bandwidth is infinite means what? It is the upper limit to the lower limit of a frequency. This is the F2 frequency and this is the F1 frequency. And the bandwidth BW, it is the infinite. Okay, so what happened in this case? We can also amplify the DC signal also. Okay, now the next one property, the zero output impedance. Our resistance, which is the output, it is equal to zero. So due to this property, we can drive the number of instruments. And the last one property, the zero voltage and current offset. If the zero voltage and current offset, then if the input is zero, then output is also zero. Output is also zero. Due to the sum, these are the property. The op-amp is behaving like an op-amp is behaving like an operational amplifier. Okay, remaining also the some property which is elaborate in the further one, but basically these are the some highlighted properties. Op-amp, he can amplify the difference between the two signal. Here inverting is a V1 and non-inverting is a V2. They can amplify the difference between the V2 minus V1. Mostly, op-amp is the differential amplifier. They can amplify the difference between the two input signal, as well as op-amp is also amplifying the common mode input signal. That is the average of the two input signal. Mostly we amplify the differential mode signal. Now, the main thing, the block diagram of our operational amplifier. So which are the block is contained in the operational amplifier? There are the majorly four block. The first one block is the input stage. The input stage, it is the dual input balance output differential amplifier. That means here V1 V2, here they can amplify the difference between the two input signal. Here dual input and dual, that means the balance output, two input and two output, so that's why it is the balance output. Now the next one stage is the intermediate stage. In the intermediate stage is the two or more dual input and balance output differential amplifier is there. Here dual input and unbalanced. Why unbalanced? Because two input and only one output is there. Okay, now the next one stage is the level shifting stage. A level shifting stage, it is a consisting the emitter follower circuit with the constant current source, and the output stage is the push pull class B amplifier. It is the complementary class B push pull amplifier, that is the output stage. Here the three types of amplifier: class A, class B, class C and class AB. A class A having the 25% only efficiency, 25% only efficiency. A class B amplifier, the efficiency is 78.5%. 78.5% is their efficiency. So that's why we prefer the class B amplifier. Thank you so much. On be the next lecture, we will be elaborating the op-amp ideal characteristic and the practical characteristic. Okay, till then, see you soon.